In this unit, we're going to review and expand on alignment angles. So why might someone want an alignment? Because of off-center steering. We should define that and make sure we're clear on it. Off-center steering is when the steering wheel is not pointed directly in the direction of travel. So if I'm going straight down the road, the steering wheel might be pointed a little to the left or the right. It does not mean a pull, though. If I ease up my grip on the steering wheel, the car is going to continue going in the correct direction. They might want alignment because of a pull. Pull's a little bit of a different animal. In the case of a pull, if I hold the steering wheel in the direction I want to go, it goes that direction. If I ease up my grip, the vehicle will tend to turn on its own. So we'd call that a pull. They might want an alignment because their tires are wearing oddly. They could be feathering, or they see camber wear on one side of the tire, or they might just be wearing out prematurely. Sometimes after you get suspension or steering component replaced, frequently, you need to get an alignment. So if we replaced struts and ball joints on a car, no doubt you're going to need to do an alignment after that. If you're replacing steering components with steering rack, tie rod ends, you virtually always need alignment. After collision repairs, so you get the chassis straightened out after a collision, some parts replaced, you're virtually always going to need an alignment after that. To check in the condition of the vehicle, occasionally you will get a customer that will come in and say, I haven't had an alignment. I've had this car 5 years, never had an alignment. I think I should get one done. You go ahead and check it and make whatever adjustments are needed. An alignment check is sometimes performed as a free service. So some shops, that's kind of an automatic thing they do. They'll check it for free and let you know if you need work. Okay, so our primary angles. These angles are the ones you're concerned with on every alignment job. So there's caster, camber, toe, and thrust line. Every time you do an alignment, you'll be looking at those angles. We also have diagnostic angles. Diagnostic angles are built into the chassis of the vehicle. They are design considerations there, but you typically don't need to check them. You only need to look at them when you have problem children, such as maybe a collision repair. The vehicle comes in, needs the alignment. You can't get the angles correct. You have to figure out what's bent, what's out of line. Or you get sometimes a vehicle with no visible damage and it passes the pre-alignment inspection, everything looks good. The numbers come up right, but it still has a pull for some reason. On a note about a pull, don't forget about spool valves and steering angle sensors. So you can have a spool valve fault in a hydraulic rack or box that'll cause a pull to one side, and the steering angle sensor in an electric steering assist system might also have a fault that causes a pull or uneven assist. SAI is steering axis inclination. Included angle is SAI plus camber. There's another angle, toe out on turns, that's actually measurable. Sometimes we can use that to find a fault. And then you've got setback, and setback is essentially it's a difference in wheelbase from one side of the car to the other. Okay, so let's expand on it a bit. So caster, the angle of the steering axis of a wheel from vertical is viewed from this side of the vehicle. So we're looking at this from the side. The front of the vehicle is over here. We see if our ball joints in this case are vertical over each other, we have zero caster. If they're leaned back like this so that they project down to the ground ahead of the wheel, that's positive caster, and the opposite would be negative caster. We're using ball joints in this case, but in some cases, like on a McPherson strut vehicle, you're going to have a lower ball joint and then an upper strut bearing. Whatever the two pivot points are that the wheel, when you turn left and right, that the wheel pivots on, that's what we're concerned with, their location. Okay. Typically, it only exists on the front of a vehicle. Occasionally, you do find it on the rear, but it's usually not of concern. Caster imbalance, so cross caster, it's frequently called. So that's a difference in the caster between the left and right sides of the vehicle. So it will cause a pull towards the most negative side of the vehicle. Caster is not considered to be a tire wearing angle. Typically, most tire wear occurs going straight down the road. Caster shouldn't affect that. Many McPherson strut suspended vehicles don't have a caster adjustment. Caster settings can occasionally, rarely, be found on the rear of a vehicle, but in many cases the alignment machines don't even recognize it, and it may require special tooling that plugs into steering knuckles and things in order to actually obtain the caster angle. Frequently it's just left as is. So camber. Camber is an angle represented by the tilt of the wheels inward or outward from vertical when viewed from the front. So we're not looking at the side anymore, we're looking at the front. So it could be the rear as well. Sorry if we're looking at the back of the car. So if the wheels tilt outwards, it's positive camber. If they tilt inwards, it's negative camber. These angles exist on the front and rear of a car. Camber imbalance or cross camber will cause a pull to the most positive side. So whatever side is leaning out most, the car will tend to pull that direction. Camber will wear tires. As you might expect, if you lean the tire over, there's more pressure on one side than the other. One side gets more wear than the other. Camber is frequently adjustable on both the front and the rear of a vehicle, and slight negative camber can improve cornering traction. Note I said slight, not extreme camber. That actually causes a loss of traction everywhere, accelerating, braking, and cornering. Toe. So toe is a distance comparison to the leading and trailing edge of the tires. As we can see in that picture there, vehicle's traveling downward. So the top frame shows you toe in, the bottom frame shows you toe out. This typically exists at both the front and rear wheels of a vehicle. Front toe errors do not cause a pull, they cause an off-center steering wheel. So if we go back to the beginning, the steering wheel is not pointed in the right direction. If we have an imbalance in toe, say with the steering wheel straight ahead, the left front wheel is pointed straight ahead and the right front wheel is pointed 20 degrees to the right. When we drive that vehicle, the wheels will center themselves. So we'll have both front wheels pointed 10 degrees out, and the steering wheel will rotate to accommodate that change. So we'll drive straight, but we get a ton of tire wear and the steering wheel's off center. This is a very common complaint. It's one of the things you have to pay attention to when you're doing alignment adjustments, so that when the customer gets a car back, everything's pointed the right way. Okay? And as it states here, this is the worst tire wearing angle. So essentially, if you have a toe problem, you're dragging the tires down the road sideways and just scrubbing the rubber off. Okay, it's frequently adjustable on both the front and rear vehicles. Rear toe errors, you don't typically refer to them as a toe problem, you call it a thrust angle problem. And thrust angle we'll expand on in a moment. So tracking. Tracking is when correct tracking would be when all four wheels are parallel to the center line of the vehicle and traveling down the road in perfect line. And that's our goal in an alignment, is to get a vehicle to track that way. One of our goals. So thrust angle. If we have a difference between the center line of the vehicle and the direction the rear wheels are traveling, we end up with a thrust angle or a thrust line error. Okay, so this is going to cause the vehicle to have a pull. So if our rear wheels are pointed to the right, the vehicle is going to pull to the left, and vice versa. Okay, it's set by the average of rear toe. So that means that even if you only have one rear wheel out of line, you're still going to have developed a thrust angle, and you're going to have tire wear problems and a pull, and off-center steering is not going to be good. Okay, so just remember that the rear of the car is important too. Some more diagnostic angles here. So we've got setback. Setback's a condition where one axle is slightly behind another. The distance between the center line of the tires is different on one side than the other. Most alignment machines will measure setback. A vehicle with front wheel setback will pull towards the side with the most setback. Vehicle with rear wheel setback will pull towards the opposite side. A rear wheel setback acts the same as it causes a thrust line error, similar to what toe does. So we get the same pull problems and everything. Some vehicles are designed with setback built in to compensate for road crown. So you may find a vehicle that has an eighth of an inch of setback on the left front wheel or something. Check the specifications. It's possible it's supposed to be that way. Setback is usually 0 to a quarter inch or 6 millimeters, so it's not much if it's designed into the chassis, if it exists at all. Okay, diagnostic angles, toe out on turn. So as I'm sure you're aware, if a vehicle is going around a corner, the inside wheel has to turn in a tighter radius than the outside. So the chassis is designed to do that. So this angle, you typically don't worry about it in an alignment, but you can measure it if you've got a vehicle that has a front, an alignment issue. You can measure it to determine if you have a bent steering arm or knuckle. Okay, diagnostic angles, SAI, steering axis inclination. So if we look at the diagram on the right here, now we're looking at a vehicle head-on, looking at the front suspension. This is sort of similar to caster, but we're looking at it from the front, not from the side. So there's like a compound angle in your front steering geometry. So if we look at it from the front, what we would see if we drew a line through your steering pivots would be steering axis inclination. All right. It helps the steering wheel return to straight ahead when you release the steering wheel. It also is a component that sets scrub radius, and it is not something that's commonly measured, but it is designed into the chassis. The only time we're going to measure this, again, is if we have a problem. Okay. Now, included angle. So if you have, you measure your SAI angle and you measure the camber angle, you end up with the included angle. So it must be equal on both sides of the vehicle, or you're going to get a pull from it. And again, this is a diagnostic angle. So let's look at what you can do to diagnose things. So if we look down here, hope you can see the cursor. Let's just pick one. McPherson strut suspension. Go to number 3 here. So let's say the SAI is less than spec and the camber is greater than spec. So in this case, we've got something's wrong. So we've made our adjustments and SAI is out of spec and we can't get camber to come into spec. It's more positive than we want and we're out of adjustment, right? So it's less and greater. And then the included angle is correct. Well, what can this mean? In this case, it would mean you have a bent control arm or a strut tower that's bent out at the top. So we're probably looking at some collision damage here, right? And we have to go and get that straightened out or we can't make our adjustments. So this text is it's table 49, this table is table 49-1 in your textbook, so you can have a look at that and go through it a little bit on your own if you like. Okay, scrub radius. So scrub radius is the distance between the center of the tire and where the SAI angle intersects with the ground. It's got to be equal on both sides of the vehicle or you'll end up with a pull. Now this is one of the angles that can be dramatically changed just by changing wheels. So just if you think about it for a little bit, if we put an odd wheel on the front of the vehicle and it had a little bit different offset on it or a different width, we would change the scrub radius on one side versus the other. And we can get some fairly erratic handling out of that when we don't want it. Okay, that's it. All right, see you in class. Bye for now.